10 people, 8 good excuse to read that.
modular production. He's currently working on buildings that are produced 100% in the factory and shipped to sites across the country, thereby reducing carbon footprint drastically and making all their projects sustainable, apart from being cost beneficial. Apart from being a practitioner, Manish also teaches at various institutions and lectures regularly at institutions across the country. I'd like to welcome Manish onto the dais.
Thank you. The pros and cons of being the last speaker of the day. You can assimilate everybody's thoughts, whoever's spoken, and then improve your own presentation. Or the con is, of course, you have the dwindling population. You have only half the people left. But nonetheless, so as this auditorium has a lot of fond memories for me, and the most was the history lectures by Professor Varkey. I am going to take a larger overview of the entire talk today of what is just digital versus non-digital, what is parametric versus non-parametric, AI before AI. So a much larger overview from the perspective of history of design, and then coming to showcasing some of the projects that we do, application, and maybe the way forward, which will be a question mark. So, shaping design futures, digital workflows in architecture and construction, which to me goes hand in hand. Our practice, which is about 20 years old now, has gone through various versions, and each version has sort of helped us understand way forward for the future. Practice is always work in progress for me. It's an experimental lab where we keep a sort of a fine balance between how to run a practice versus what we find for the future as a language for ourselves. So it's sort of a disruptive practice. I believe in controlled chaos, and that is something that one is trying to learn over the last 20 years. This image is very interesting to me and very important. It shows a bunch of manual draftsmen, but it also shows a hierarchy. It shows a hierarchy of draftsmen versus architects and engineers. The one who are seated are checking the drawings, the one who are standing are drawing. And there is a certain hierarchy that always has been there in this design industry and of late. So when I come to general overview of the design time period, and these are important for me, when I say the medieval versus industrial to digital and to the AI, what I mean by that is medieval to me was more community and craft oriented. It was not based on the formal education as what we understand it today. It was built on master craftsmen and other craftsmen. It was other industries put together. It was not the architect, engineer, and the builder as we understand today, but it was a more organic, fluid system of cultural continuity of collective knowledge and craftsmanship. It was more of oral transmission and hands-on building. It was something which was not always drawn on paper, was not always engineered on computers, but it was a more collective knowledge that was used to build or to craft something. The space belonged to the community. It was symbolic, it was contextual, it was deeply embedded in the vernacular wisdom. Now, I'm not saying one is better than the other, but with the time, things change, and there's a need to change at that time. With the Industrial Revolution and going on to from industrial to the postmodern architecture, or even to the post-war architecture, there was a need for efficiency, there was a need for mass production and systematic thinking. The new terms of an architect, engineer, structural engineer, and a builder came into picture. And when you have to direct a language, when you have to create a mass-produced city, you need modularization, you need typology, you need standard dimensions, and you need to be able to draw things. The design was about control and scalability because numbers mattered. It had to be scaled up. cities were getting filled. You read Hard Times, Charles Dickens, you read anything that's about industrial era, you had to fill numbers of the city, and the craft-oriented approach did not work anymore. So mass housing and Taylorism in planning was extremely important. It was the need of the hour. With the 80s came the digital era, and we call it the behavioral or the cognitive era, where the design driver was more user-centric. By the time people were tired of what was going on with the cookie-cutter approach, there were new disruptive thinkings. The computer had and I'm not talking about right now parametric versus non-parametric. I'm talking about only CAD or machines being introduced, or the digital era at its start. And by the time it progressed, it started talking about user-centered design, interactivity, and feedback loops. Something that you learn, something that you don't. It's not the mastermind of one architect or an engineer, but it's a more collaborative process. You have continuous feedback loops, you understand what works, what doesn't work, and the term parametric came in. But it's not that parametricism was not there in medieval times. It was there. It's just, this is where I differ from a conventional term of what parametric design is. Everybody understands parametric design. It was introduced after the digital age. But anything that is based on parameters, anything that's based on a certain proportioning system, and it's non-cookie cutter, can be called parametric. There have been enough examples in the medieval architecture of parametric design, which is non-digital. Analog parametric design is what I call it. So it's more responsive environments, and the design is more about interaction and adaptation, and the building responds to various conditions, thousands, millions, sites, and program and user behavior. I'm not touching AI. I deleted those slides after the last presentation. There's enough said on that. But coming to a more summing up of the entire thing, where medieval was mostly ruled by master craftsmen, it was intuitive, it was iterative, it was collaborative, bespoke, and community-based. An industrial era was mainly ruled by the architect and the engineer. It was about logic, it was about standardization, hierarchical, cookie cutter, and it became a more statistical approach. Whereas the digital age, another person added was a coder. But coder is just one of them. You had the scientists, you have other streams that you start taking data from. The intuition, the logic comes together. It's optimization, it's codependent, it's modular. The behavioral and the cognitive part takes over. AI, whether it's independent, augmented intuition, pattern recognition, neural network, emergent, co-authorship, and cobotic. It's something that I relate more with the medieval way of thinking, somewhere we're coming the whole circle, rather than, okay, I will come from here to a more typological and the modular analog. So this is the broad-based what I have tried to understand. That when it comes to the kind of design, there's a parametric design or a parameter-driven design, and then there is a modular design. Something which is more intuitive, something which is more sort of not based on feedbacks, something not based on parameters, and both exist in analog and in the digital world. Of course, in the digital world, there are various softwares that sort of lead you to these kind of things, and various kinds of visualization. But in the non-parametric sense, there's a general timeline that I have understood with my own practice and with the projects which have been done. It starts with, and I've taken only one project in particular right now, which is the Bilbao Guggenheim, because it sparked off a new way of thinking. We call it the Bilbao effect. Frank Gehry brought in a new software, which has become Gehry Technologies, and it sparked off a new revolution or a new way of thinking. He was inspired from Picasso's painting. He wanted to look at those cubist sort of thing. There is one theory which says that the whole idea of titanium panels and the planes and things were an inspiration from a cubist painting of Picasso. There was a sketch, annotation to that, the whole craft of building making, and I'm going to be mentioning Mario Capo here, he talks about the ability to be able to make a certain building is the ability of an architect to be able to annotate it. How well you can annotate that building defines the language of that building. So, simulation, engineering, and fabrication leads you to a certain kind of building. Now, this example is extremely important. And when, during one of his talks at Google, Mario Capo, he mentions very clearly, and his references are very interesting. He refers to Gary's architecture as fish, because it was the first time when he wanted to build the fish. Dassault was approached. You got Katia. Katia was brought down. It was very expensive in those days. Gary Technologies invested, put together. They brought down for a more human use. For the use for architects, it became simpler. And after that, as per Mario, he made multiple fish, because each form was a derivative from the same principle. It was just various types of fish. But with the digital age, with the algorithmic thinking coming in, with data-driven design, he calls it the dog. Why the dog? Because of the typology. It's not based on form, it's not based on shape. You don't know the shape in the beginning. It's a data-driven design. And with that, it could be anything. It becomes a more open-ended future. It is not an intuitive, form-based or a certain idea-based design, but it becomes a more exploratory design for the future, where even the designer does not know what you're designing.